Hello everyone. Today is July 1st, 2025, a Tuesday. I'm about to introduce a trending article from the archives. It's a really interesting one. Let's see what have we got here. The title is The Automated LLM Speedrunning Benchmark, Reproducing Nanogd Improvements. And the title is Jeeves Web C. We are at the new 506.22419 one. It's long. Okay, so let's dive into this. This paper is basically asking a super cool question. You know how AI is getting really good at stuff. Well, can it get good at making itself better? Like, can an AI reproduce the work of a human AI researcher? So the researchers here create something called the Automated LLM Speedrunning Benchmark. Think of it like a video game speedrun, but for AI. The goal wasn't to beat a game, but to train a small language model called NanoGPT as fast as humanly, I guess, artificially possible. So the problem this paper is trying to solve is automated. Scientific progress depends on being able to reproduce experiments. Someone else needs to be able to follow my steps and get the same result. This paper checks if car and eyes are good enough to do that on their own. So here's how they did it. They took a series of 19 real-world improvements made by human researchers, who were all competing to speed up and up train. Then gave an AI agent the code for one record, and a hint about how to get to the next record. The hints range from simple pseudo-node to a full mini paper. And the results? Oh, this is the best part. Even most advanced eyes, like ones from Meta and OpenAI, they really struggled. They could only recover a fraction of the speed up that humans achieved. Like, the best models only got about 40% of the way there, even with detailed hints. It's super funny is that sometimes giving the AI more information like a detailed paper actually made it perform worse than just giving it simple pseudo-node. It seems like the AIs got confused by too much context, which is, incredibly human of them. This is a huge deal compared to other technologies, because it's not just about generating code. It's about understanding a scientific goal, novel ideas correctly. It's a reality check on the dream of fully automated AI scientists. So how could this apply to our daily lives? If AI gets good at this, it could accelerate progress everywhere. Let's take 3 examples. First, machine translation. Imagine a new research paper comes out with a breakthrough in translation. Instead of waiting for developers to implement it, your translation type AI could read the paper, understand the new technique, and update itself automatically. You get better translations almost instantly. Second, better bots and dialogue systems. A developer could read up on the latest research and say, empathetic conversation with factual accuracy. It could then modify its own code to become a better, more helpful or more understanding conversationalist. It would be like your virtual assistant going to school on its own. And third, information extraction and text summarization. Think about a scientist using an AI to summarize research. Right now, it just summarizes text. But with this tech, the AI could also try to replicate the code from the paper to verify that the results are even real before it summarizes them. That would be a massive leap in trustworthiness. So yeah, this paper shows we're not quite there yet. Automating scientific reproduction is still a huge challenge, but it also gives us a clear benchmark, a way to measure our progress, on the path to creating AIs that can truly help us innovate. Fascinating stuff, really.